Performance evaluation. We all need a measure to compare our performance with the expected performance, and hence, performance evaluation comes into the picture. Performance measure can be done using an evaluation metric. What is the need for an evaluation metric, you may ask? Loss of calculation in other areas is one of the primary needs for an evaluation metric. In most of the deep learning tasks, such as classification, regression, or image generation, it is pretty easy and straightforward to evaluate the performance of a model based on the solution space, which is finite and not very large. In most classification problems, the number of labels is fixed, which makes it possible to calculate the score for each class and hence makes it possible to calculate the loss or offset from the ground truth. Ground truth can be considered as the expected outcome or the expected results from a certain action. And the offset from the ground truth is basically the deviation from the expected value or the expected outcome. In case of image generation, the resolution of the output and the ground truth is fixed. Therefore, we can calculate the loss or offset from the ground truth at a pixel level. In case of regression, the number of values in the output is fixed and hence loss can be calculated for each value, even though the possibilities for each value is infinite. Issues in loss calculation in NLP. In case of NLP, even if the output format is predetermined, the dimensions may not be fixed. If we want a model to output a single sentence, it will be counterintuitive to restrict the number of words in that sentence because we know that there are multiple ways to express the same information. Now, if I ask you to choose the incorrect caption for the image above from the following captions or the following options: a car is in front of a house, a car on the road in front of a house, a grey car on the road in front of the house, grey sports car in front of the house. You can choose any of them and still be correct. None of the options given above is incorrect. Only they vary in detail. If the ground truth for this image in our dataset is a grey car on the road, how will you teach a model using the ground truth label that all the four given options are correct? Not so easy, isn't it? Why does it matter to have a good evaluation metrics? The main purpose of developing these AI solutions is to apply them to real world problems and make our lives easier and better. But our real world is not a simple one. So, how do we decide which model to use for a particular problem? That is when these metrics come handy. If we are trying to solve two problems with one model, we would want to know the model's performance on both of these tasks to make an informed decision, to be aware of the trade offs we are making. This is also where the goodness of a metric comes in. The real world is full of biases, and we don't want a solution to be biased as it can have inconceivable consequences. A quick example: if we are translating a text from a language X to English for a particular sentence, if we are talking about group A, it is translated to they did a good job. In contrast, for group B, it is translated to they did a great job. That is a crystal clear sign that a model is biased towards group B. Such biases should be known before it is deployed in the real world, and metrics should help us in surfacing these. Even the learning biases are more to do with training data and less to do with model architecture. I personally have a feeling That metric for capturing biases or standard biases would be a good practice to adapt.